Picture this. You're standing on a beach 540 million years ago, watching waves crash against an alien shore. The water is crystal clear, but eerily empty. No fish dart between the rocks. No crabs scuttle across the sand. No seaweed sways in the current. Just endless, barren blue stretching to the horizon. Because in this timeline, the most explosive chapter in Earth's history never happened. The Cambrian Explosion, that incredible burst of evolutionary creativity that gave birth to almost every major animal group we know today, simply didn't occur. What if I told you that this single event, lasting just 25 million years, determined whether complex life would flourish or remain trapped in simplicity forever? That without it, Earth might have stayed a planet of microscopic blobs and bacterial mats for billions of years longer? Today, we're diving into one of the most mind-bending what-ifs in natural history. We're going to explore a world where the greatest biological revolution never ignited, where the evolutionary fuse that lit up our planet's diversity simply fizzled out. Now, before we plunge into this alternate timeline, let me paint you a picture of just how dramatic the real Cambrian explosion actually was. We're talking about an evolutionary arms race so intense, so rapid, that it makes modern technological advancement look glacial by comparison. In the span of just 25 million years, life went from simple, soft-bodied creatures that barely left fossils to an incredible menagerie of bizarre, complex animals with shells, spines, claws, and eyes. Think about that for a second. 25 million years might sound like forever to us, but in geological terms, it's the blink of an eye. It's like watching a fireworks display where every rocket launches simultaneously, painting the sky with impossible colours and patterns. Except instead of lasting minutes, this biological fireworks show rewrote the rules of life on Earth forever. But what if that explosion never happened? What if the fuse never lit? What if Earth's most creative moment in biological history was nothing more than a dud? The implications are staggering. Without the Cambrian explosion, we wouldn't just be missing a few interesting fossil specimens in museums. We'd be looking at a fundamentally different planet, one where the very concept of complexity might never have taken hold. No vertebrates, no arthropods, no mollusks, no echinoderms. The entire foundation of animal life as we know it would simply not exist. And here's the kicker that's going to keep you watching until the very end. Without this explosion, there's a very real possibility that you and I would never have existed at all. That intelligence itself might be nothing more than a cosmic impossibility, a dream that never had the chance to wake up. So buckle up, because we're about to embark on a journey through the most important 25 million years in Earth's history, and then we're going to erase them completely. We're going to explore what our planet would look like if evolution had taken a permanent coffee break right when things were getting interesting. But first, we need to understand what made the Cambrian explosion so explosive in the first place. Picture Earth around 540 million years ago. For over 3 billion years, life had been playing it safe. Sure, there were some interesting developments. Single-celled organisms had figured out photosynthesis, invented sex, and even started cooperating to form simple multicellular creatures. But for the most part, life was content to exist as microscopic specks floating around in ancient seas. Then something changed. Something big. It was like evolution suddenly discovered rocket fuel and decided to go completely insane with it. Within just a few million years, the fossil record explodes with an incredible diversity of complex animals. We're talking about creatures so bizarre they make science fiction look tame. There was Opabenia, with its vacuum cleaner-like proboscis and 5 mushroom-shaped eyes. Hallucigenia, covered in defensive spines and walking on stilts. Anomalocaris, the ocean's first apex predator, reaching lengths of over 6 feet and sporting flexible arms that could grab prey. These weren't just bigger versions of what came before. These were entirely new ways of being alive. For the first time in Earth's history, animals developed hard shells and exoskeletons. They invented eyes that could actually see, not just detect light and shadow. They created sophisticated nervous systems that could process complex information and coordinate movement. They developed specialized organs for feeding, breathing, and reproduction. It was as if life suddenly discovered the instruction manual for complexity and decided to try out every possible combination at once. The Cambrian seas were like nature's ultimate laboratory, where evolution was running hundreds of experiments simultaneously, testing out new body plans, new survival strategies, new ways to interact with the environment. and the speed of it all was absolutely breathtaking. In evolutionary terms, this was like going from the horse and buggy to the space shuttle in the span of a single generation. The rate of innovation was so rapid that paleontologists are still arguing about exactly how it was possible. But here's where our alternate timeline begins to diverge. What if those crucial environmental conditions that triggered the explosion never aligned? What if the chemical cocktail that made complex life possible never mixed in just the right way? To understand this, we need to dig into the perfect storm of factors that made the Cambrian explosion possible in the first place. It wasn't just one thing that triggered this biological revolution. It was a convergence of multiple factors, each one necessary, but none sufficient on its own. First, there was the oxygen revolution. For billions of years, Earth's atmosphere contained virtually no free oxygen. Most early life forms were anaerobic, meaning they didn't need oxygen to survive. In fact, oxygen was actually toxic to most of them. But around 2.4 billion years ago, cyanobacteria figured out how to use photosynthesis to split water molecules, releasing oxygen as a waste product. This caused the Great Oxidation Event, which was actually an extinction event for most life at the time. But here's the thing. Complex multicellular life absolutely requires oxygen. It's the fuel that powers complex metabolisms, the energy source that makes it possible to build and maintain sophisticated body structures. Without adequate oxygen levels, life remains stuck in the slow lane, limited to simple forms that can get by on minimal energy. So in our alternate timeline, what if oxygen levels never reached that critical threshold? What if the cyanobacteria never quite figured out the photosynthesis trick? Or what if some other factor kept oxygen levels perpetually low? Without sufficient oxygen, the metabolic foundation for complex life would never have been laid. Evolution would have remained trapped in a world of simple, energy-efficient organisms, but oxygen was just the beginning. The Cambrian explosion also required the right temperature conditions. In the hundreds of millions of years leading up to the Cambrian, Earth experienced several extreme ice ages, periods when ice sheets extended almost to the equator, creating what scientists call snowball Earth conditions. These ice ages were brutal for life, but they also set the stage for the Cambrian explosion in several crucial ways. When the ice finally melted, it created massive changes in ocean chemistry, flooding the seas with nutrients that had been locked up in ice and rock for millions of years. This nutrient influx created the perfect conditions for a biological boom. The ice ages also acted as evolutionary pressure cookers. Only the most adaptable organisms survived these extreme conditions, and when the ice retreated, these survivors found themselves in a world full of empty ecological niches waiting to be filled. It was like clearing out a crowded ecosystem and giving evolution a blank canvas to work with. In our alternate timeline, what if these ice ages never happened? What if Earth's climate remained stable and unchanging for hundreds of millions of years? Without the dramatic environmental pressures and the subsequent ecological opportunities created by these ice ages, evolution might have remained content with the status quo. There would have been no driving force pushing life toward greater complexity, no empty niches creating opportunities for innovation. But even oxygen and climate change weren't enough on their own. The Cambrian explosion also required some crucial genetic innovations. Around this time, evolution invented some of the most important molecular tools for building complex organisms. Hox genes, which control body plan development, allowed organisms to create repeated body segments and specialized appendages. Collagen, a structural protein, made it possible to build strong, flexible tissues. And various genes controlling eye development opened up the entirely new sensory world of vision. These genetic innovations were like giving evolution a whole new toolkit. Suddenly, organisms could experiment with body plans that had never been possible before. They could create specialized structures for different functions, develop sophisticated sensory systems, and coordinate complex behaviors. In our alternate timeline, what if these crucial genetic innovations never arose? What if the random mutations that led to Hox genes or collagen simply never occurred? Without these molecular building blocks, evolution would have remained limited to the simple body plans that had dominated life for billions of years. But perhaps the most important factor of all was ecological. The Cambrian explosion wasn't just about individual organisms becoming more complex. It was about the emergence of complex ecosystems, with predators and prey, competition and cooperation, arms races and evolutionary feedback loops. Before the Cambrian, life was relatively peaceful. Most organisms were filter feeders or grazers, quietly going about their business without much interaction. But during the Cambrian, predation emerged as a major evolutionary force. Suddenly, organisms needed to develop defenses against being eaten, which drove the evolution of shells, spines, and armor. Predators, in turn, needed to develop better ways of catching and consuming their prey, leading to innovations in mobility, sensory systems, and feeding mechanisms. This predator-prey arms race created a positive feedback loop that drove rapid evolutionary innovation. Each new defensive adaptation spurred the evolution of new offensive capabilities, which in turn drove the development of even better defenses. It was like an evolutionary nuclear arms race, except instead of weapons, organisms were developing increasingly sophisticated biological technologies. In our alternate timeline, what if predation never evolved? What if organisms remained content to filter, feed, and graze, never developing the hunting instincts that would trigger this biological arms race? Without the evolutionary pressure created by predator-prey interactions, there would have been little driving force for the rapid innovation that characterized the Cambrian Explosion. So now we're beginning to see just how many things had to go exactly right for the Cambrian Explosion to occur. Oxygen levels, climate change, genetic innovations, ecological interactions. All of these factors had to align in just the right way at just the right time. It was like winning the cosmic lottery, except instead of money, the prize was the entire future of complex life on Earth. And that's what makes our alternate timeline so fascinating and so terrifying. Because when you really think about it, the Cambrian Explosion wasn't inevitable. It was the result of an incredibly specific set of circumstances that might never have occurred at all. But what does this alternate world actually look like? Let me take you on a journey through this timeline where complexity never conquered Earth. It's the year 2024, but not the 2024, you know. You're still standing on that same beach, but now you're witnessing 540 million years of evolutionary stagnation. The ocean before you tells a story of missed opportunities. Instead of the vibrant marine ecosystems we know today, you're looking at vast bacterial mats stretching across the seafloor like living carpets. These microbial communities are incredibly sophisticated in their own way, don't get me wrong. They've perfected chemical communication, developed intricate metabolic partnerships, and created some of the most efficient energy processing systems on the planet. But they're still fundamentally simple. Picture diving beneath these waves. In our timeline, you'd encounter coral reefs teeming with fish, crustaceans hiding in rocky crevices, mollusks filtering nutrients from the water. But in this alternate world, you'd find something far more alien. The seafloor is dominated by thick, spongy mats that pulse with chemical signals. These aren't just random bacterial colonies. They're vast interconnected networks that span entire ocean basins, communicating through molecular messages that travel like slow-motion lightning across the deep. Some of these microbial cities have grown incredibly large. There are bacterial towers that rise hundreds of feet from the ocean floor, built layer by layer over millions of years. These structures are architectural marvels in their own right, with internal channels that circulate nutrients and waste products, specialized zones for different metabolic processes, and even primitive forms of collective decision-making. But they're still just bacteria. Really, really sophisticated bacteria, but bacteria nonetheless. And here's where it gets truly mind-bending. Without the evolutionary pressure of predation, without the arms races that drove complexity in our timeline, these microbial communities have had 540 million extra years to perfect their craft. They've become unimaginably efficient at extracting energy from their environment, recycling nutrients, and maintaining homeostasis. In many ways, they're more successful than the complex ecosystems we're familiar with. But success isn't the same thing as complexity. These bacterial empires might cover the entire ocean floor. They might process more energy than all of Earth's current ecosystems combined. But they're still fundamentally limited by their simple architecture. They can't develop nervous systems. They can't evolve mobility beyond simple chemical gradients. They can't develop the sensory sophistication that would allow them to perceive and respond to their environment in the way complex organisms do. Now you might be wondering, what about the land? Surely something interesting must have evolved on dry ground during all this time. Well, here's where our alternate timeline gets even more stark. Without complex marine life to establish the foundation for terrestrial ecosystems, land remains largely barren. Think about it. In our timeline, the transition from sea to land was driven by organisms that had already developed sophisticated body plans, circulatory systems, and sensory organs in marine environments. Fish developed lungs and limbs. Marine arthropods colonized freshwater and eventually terrestrial habitats. Marine plants established the photosynthetic foundation that made terrestrial food webs possible. But in our alternate world, none of that evolutionary groundwork was ever laid. The land is dominated by bacterial mats and primitive algae, much like the very earliest terrestrial communities in our own timeline. There are no forests, no grasslands, no complex soil ecosystems, just endless expanses of microbial crusts punctuated by the occasional stromatolite formation. The atmosphere itself tells a different story. Without the massive biomass of complex marine life cycling carbon, oxygen levels have remained relatively stable but low. There's enough oxygen to support microbial life, but not nearly enough to fuel the high-energy metabolisms that complex organisms require. The sky has a different quality to it, clearer in some ways, but missing the dynamic interplay between atmospheric gases that complex ecosystems create, and the silence. Oh, the silence is profound. There are no bird songs, no insect buzzes, no whale calls echoing through the ocean depths. The planet hums with the quiet chemical conversations of microbes, but it lacks the acoustic richness that comes with complex nervous systems and vocal communication. But here's where things get really interesting. Just because complex multicellular life never evolved doesn't mean evolution stopped entirely. Remember, we've given natural selection an extra 540 million years to work with bacterial and simple multicellular forms. The results are absolutely fascinating. Some bacterial communities have evolved primitive forms of collective intelligence. Not consciousness as we understand it, but distributed decision-making systems that can process environmental information and coordinate responses across vast distances. Imagine bacterial mats that can predict seasonal changes, redirect nutrient flows, and even engage in something resembling long-term planning. They're like planet-scale neural networks operating at geological timescales. Other microbial communities have developed incredible specialization. There are bacterial colonies that have essentially become living factories, converting raw materials into complex organic compounds with precision that would make our best chemical engineers weep with envy. Some have evolved to process radiation, others to extract metals from rock, still others to manipulate atmospheric chemistry on a regional scale. In the deep ocean, where pressure and darkness create unique evolutionary niches, some of the most remarkable developments have occurred. There are bacterial communities that have learned to harness geothermal energy so efficiently they've created their own localized climate systems. Warm water currents generated by these microbial power plants support oases of slightly more complex life. Primitive multicellular organisms that never quite made the leap to true complexity, but represent the absolute pinnacle of what's possible without the Cambrian toolkit. And then there are the almost complexities. These are the organisms that came tantalizingly close to breaking through to true multicellular sophistication, but never quite made it. They exist in this fascinating liminal space between simple and complex, like evolutionary might-have-beens frozen in time. Picture colonial organisms that look almost like primitive animals, but lack the crucial innovations that would make true complexity possible. They might have hundreds of specialized cells working together, primitive circulatory systems, even basic sensory capabilities. But without the genetic toolkit that the Cambrian Explosion provided, without Hox genes to organize body plans, without collagen to build sophisticated tissues, without the neural architecture that enables complex behavior, they remain forever stuck at the threshold of complexity. These almost animals are perhaps the most haunting inhabitants of our alternate Earth. They represent all the potential that never quite realized itself, all the evolutionary experiments that came so close to succeeding, but fell just short of the mark. They're living reminders of what might have been, organisms that seem to yearn for complexity they can never achieve. But the most profound difference in this alternate timeline isn't biological, it's philosophical. In our world, the emergence of complex life eventually led to consciousness, to self-awareness, to beings capable of contemplating their own existence and the nature of reality itself. We are, as far as we know, the universe becoming aware of itself. In this alternate timeline, that awakening never occurs. The planet remains forever unconscious, processing information through chemical gradients and molecular signals, but never developing the kind of integrated awareness that could ask questions about its own nature. There are no minds to wonder about the stars, no consciousness to contemplate the meaning of existence, no intelligence to unravel the mysteries of physics and chemistry that govern reality. It's a world of incredible biological sophistication in some ways, but also of profound emptiness. All that complexity, all that processing power, all that evolutionary creativity, but no awareness to appreciate it or understand it. Like the most beautiful symphony ever composed, playing in an empty concert hall with no ears to hear it. And yet there's something almost peaceful about this alternate Earth. Without consciousness comes the absence of suffering. Without awareness comes freedom from existential anxiety. This is a world without war, without environmental destruction driven by conscious choice, without the peculiar forms of misery that seem to accompany self-awareness. But it's also a world without love, without curiosity, without the joy of discovery, without the profound satisfaction that comes from understanding something new about the universe. It's a world that processes information but never experiences wonder. Now you might be thinking that this alternate timeline sounds far-fetched. Surely something would have eventually triggered complexity, right? Some environmental catastrophe, some genetic accident, some random mutation that would have kicked off the evolutionary arms race that we call the Cambrian Explosion. But here's the thing that'll keep you up at night. The more we learn about the Cambrian Explosion, the more we realize just how improbable it actually was. It required such a precise alignment of factors, such a specific sequence of events, that it's entirely possible it could have never happened at all. And this brings us to one of the most chilling realizations about our alternate timeline, the Great Filter Hypothesis. This is the idea that somewhere in the evolution of life from simple organic compounds to spacefaring civilizations, there's a step so difficult, so improbable, that almost no species ever makes it through. In our real timeline, we've already passed through what might be the most difficult filter of all, the emergence of complex multicellular life. But in our alternate world, life remained trapped at this filter for over 500 million years longer than it should have. And here's the terrifying part. If the Cambrian explosion represents such a narrow bottleneck that it might never have happened, what does that say about the likelihood of intelligence emerging elsewhere in the universe? Think about it. We've spent decades searching for signs of alien intelligence, listening for radio signals, looking for megastructures around distant stars. But what if most planets that develop life never make it past the bacterial stage? What if the cosmos is filled with worlds just like our alternate Earth, teeming with microbial life but forever locked out of complexity? This alternate timeline doesn't just change Earth's history, it fundamentally alters our understanding of how common or rare intelligence might be in the universe. If the Cambrian explosion was a 1 in a billion chance event, then perhaps the silence we hear when we listen to the stars isn't because intelligence is hiding, or because civilizations destroy themselves. Maybe it's because intelligence almost never gets the chance to emerge in the first place. But let me take you deeper into this world that never was. Because even though complex animals never evolved, evolution didn't just stop. It found other pathways, other possibilities that we can barely imagine. And some of these alternative evolutionary experiments are absolutely mind-blowing. Consider the megamats. These are bacterial communities that have grown so large and so integrated that they've essentially become planetary organs. Picture bacterial colonies that span entire continents, connected by chemical communication networks that pulse with information flows across thousands of miles. These aren't just random bacterial growths, they're coordinated, purposeful systems that manage global biogeochemical cycles with precision that makes our climate models look like children's drawings. One of these megamats has learned to regulate ocean temperature by controlling the distribution of heat-absorbing pigments across its surface. Another has developed the ability to trigger or prevent ice ages by managing atmospheric gas concentrations. A third has become a living pharmacy, producing complex chemical compounds that maintain ecological balance across multiple ocean basins. These systems represent a form of planetary intelligence that's completely alien to our way of thinking. They don't have brains or nervous systems as we understand them, but they process information, make decisions, and coordinate responses on a scale that dwarfs anything complex life ever achieved. They're like living planets, conscious in ways that we can't even begin to comprehend. And then there are the temporal specialists. These are bacterial communities that have evolved to operate on completely different timescales than anything in our world. Some process information and respond to environmental changes over periods of thousands of years, essentially becoming living geological processes. Others operate on microsecond timescales, creating chemical reactions and information processing systems that happen faster than complex nervous systems could ever manage. Imagine bacterial computers that can solve certain types of problems by literally growing the solution, using evolutionary processes accelerated to incredible speeds. These systems can test millions of chemical combinations in parallel, evolving optimal solutions to environmental challenges in real time. They're like biological quantum computers, using the power of parallel evolution to solve problems that would take our best supercomputers millions of years to crack. But perhaps the most remarkable development in this alternate timeline is the emergence of what we might call evolutionary time travel. Some bacterial communities have learned to encode environmental information in their genetic material with such precision that they can essentially predict future conditions based on past patterns. They've become living libraries of planetary history, storing information about climate cycles, chemical compositions, and environmental changes going back hundreds of millions of years. These temporal databases allow them to prepare for future environmental changes with uncanny accuracy. When a particular combination of atmospheric conditions begins to develop, they can access genetic memories of similar conditions from millions of years ago and begin preparing appropriate responses before the changes fully manifest. It's like having a crystal ball made of DNA. Now you might wonder, with all this sophisticated information processing and planetary scale coordination, couldn't some form of consciousness eventually emerge from these systems? And here's where our alternate timeline reveals one of the most fundamental truths about the nature of awareness itself. Consciousness, as we understand it, isn't just about information processing power, it's about integration, about bringing together diverse streams of information into a unified experience. The bacterial megasystems in our alternate world can process vastly more information than any human brain, but they do so in a distributed, non-integrated way. Each part of the system responds to local conditions without any central awareness that could experience the whole. It's like the difference between a vast network of individual calculators and a single computer that can run complex programs. The network might be able to perform more calculations, but it can never develop the integrated processing that gives rise to subjective experience. The bacterial systems in our alternate world are trapped in this distributed processing mode, forever powerful, but forever unconscious. And this raises profound questions about the nature of consciousness itself. In our timeline, consciousness emerged from the complex neural networks that the Cambrian Explosion made possible. But what if consciousness requires not just complexity, but a very specific type of complexity? What if awareness is not an inevitable outcome of information processing, but a rare and precious accident that depends on exactly the right kind of biological architecture? Our alternate Earth suggests that you can have incredible sophistication, planetary scale intelligence, and evolutionary creativity without ever developing the integrated awareness that characterizes consciousness. It's a world of vast, alien intelligence that never knows itself, never questions its own existence, never experiences wonder or curiosity or the desire to understand. But let's push this thought experiment even further. What if, in this alternate timeline, something else entirely had filled the ecological niche that complex animals occupy in our world? Evolution is endlessly creative, and given 540 million extra years to work with, it might have found completely different solutions to the problems that complexity typically solves. Consider the possibility of macroviruses. In our world, viruses are simple parasites that hijack cellular machinery to reproduce. But given enough time and the right selective pressures, they might have evolved into something far more sophisticated. Picture viral systems that have learned to coordinate the behavior of entire bacterial communities, essentially using microbial cities as their bodies. These macroviruses might have developed the ability to rapidly reconfigure bacterial networks, switching between different functional modes depending on environmental conditions. One moment, a bacterial mat might be optimized for photosynthesis and energy production. The next, the viral coordinators might restructure it for defense against chemical threats, or for long-distance communication with other bacterial communities. It's a form of complexity that's based not on permanent multicellular structures, but on dynamic reconfiguration of existing systems. Instead of growing complex bodies, these organisms would reshape their environment to serve as their bodies. They'd be like shapeshifters on a planetary scale, never quite the same twice, but always purposeful, always adapted to current conditions. Or consider the possibility of crystalline life. In our timeline, life is based on carbon chemistry and cellular architecture. But given different evolutionary pressures and a lot more time, life might have learned to incorporate inorganic materials in ways we can barely imagine. Picture organisms that grow living crystal matrices, using mineral structures as both skeleton and nervous system. These crystalline entities might have evolved forms of information storage and processing that make DNA look primitive. They could encode vast amounts of information in crystal lattice structures, create mechanical computing systems using mineral formations, and even develop forms of reproduction that involve growing new crystal organisms from seed structures. The really mind-bending part is that these crystalline life forms might operate on geological timescales. They could think thoughts that take thousands of years to complete, make decisions based on environmental patterns that span millions of years, and engage in conversations that unfold over geological epochs. They'd be like living mountains, conscious in ways that biological organisms could never achieve. But here's what's truly haunting about all these alternative evolutionary pathways. None of them lead to us. None of them create beings capable of looking up at the stars and wondering what's out there. None of them develop science, art, music, literature, or philosophy. They're all incredibly sophisticated in their own ways, but they're also fundamentally alien to everything we value about consciousness and intelligence. This is the deepest tragedy of our alternate timeline. It's not just that complex animals never evolved. It's that all the things that make existence meaningful to us never had the chance to emerge. There's no love in this world, because there are no individuals capable of forming emotional bonds. There's no creativity, because there's no consciousness to imagine possibilities beyond current reality. There's no sense of beauty, because there are no minds capable of aesthetic appreciation. It's a world that might be objectively more successful than ours in terms of energy efficiency, environmental stability, and long-term sustainability. But it's also a world without meaning, without purpose, without the kind of subjective experience that makes existence worth having. And this brings us to perhaps the most important question of all. What does this alternate timeline tell us about our own world, our own existence, our own future? If the Cambrian Explosion was such an improbable event, if consciousness and complexity are such rare and precious outcomes, then what responsibility do we have as the beneficiaries of this cosmic lottery win? In our timeline, we often take consciousness for granted. We assume that intelligence is somehow inevitable, that given enough time, evolution will always find a way to create minds capable of understanding the universe. But our alternate Earth reveals just how wrong this assumption might be. Consciousness isn't the natural endpoint of evolution. It's a miraculous accident that might never happen twice. And this realization should absolutely terrify us. Because if we're living in the aftermath of a cosmic lottery win, if our very existence depends on a chain of improbable events that stretches back over 500 million years, then we're not just rare, we might be unique, not just on Earth, but in the entire observable universe. Think about the implications of this for a moment. We've been searching for extraterrestrial intelligence for decades, listening for radio signals, scanning the skies for signs of advanced civilizations. But what if the Great Silence isn't because alien civilizations are hiding, or because they've destroyed themselves? What if it's because most planets never make it past the bacterial stage? What if the universe is filled with worlds just like our alternate Earth, teeming with microbial life but forever locked out of complexity? This would mean that when we look up at the night sky, we're not seeing a cosmos filled with potential friends and enemies and fellow travelers on the journey of consciousness. We're seeing a vast graveyard of missed opportunities, billions of worlds where complexity almost emerged but never quite made it over the finish line. But let's dig deeper into what this alternate timeline teaches us about the nature of evolutionary innovation itself. Because one of the most striking things about our imaginary world is how evolution found ways to be incredibly creative within the constraints of simplicity. The bacterial megasystems, the temporal specialists, the crystalline entities, these aren't failures of evolution. They're alternative forms of success that are completely alien to our way of thinking about life. This suggests something profound about the nature of possibility itself. Evolution isn't trying to create consciousness or complexity or intelligence as we understand it. It's simply trying to find ways for information to persist and replicate in an ever-changing environment. In our timeline, that led to brains and nervous systems and eventually to minds that could contemplate their own existence. But in countless other possible timelines, it might lead to forms of information processing that are equally sophisticated but utterly different. Picture bacterial communities that have learned to encode information in quantum states, creating biological quantum computers that can solve certain types of problems instantaneously. or viral networks that use the entire planetary electromagnetic field as a communication system, turning the planet itself into a single vast neural network, or crystalline matrices that store information in dimensional folds of space-time, creating forms of memory that persist across cosmic epochs. These alternative forms of complexity are so alien to our experience that we might not even recognize them as intelligence if we encountered them. They operate on different timescales, use different substrates, and process information in ways that have no parallel in biological systems. They're like alternate forms of physics made manifest in living systems. And here's where things get really mind-bending. What if some of these alternative forms of complexity are actually superior to biological intelligence in certain ways? What if consciousness and self-awareness, the things we prize most about our own existence, are actually evolutionary dead ends that prevent organisms from achieving even greater forms of sophistication? Consider the limitations of consciousness. We can only hold a few pieces of information in our awareness at any given time. Our decision-making is biased by emotions, limited by cognitive shortcuts, and constrained by the need to process information sequentially. We're brilliant at some things, but absolutely terrible at others. Now compare that to the bacterial megasystems in our alternate timeline. They can process vast amounts of information in parallel, make decisions based on complete environmental data rather than limited samples, and coordinate responses across planetary scales without the kind of internal conflicts that plague conscious minds. They might be unconscious, but they're also unencumbered by the psychological limitations that come with self-awareness. It's like comparing a single human trying to manage a global economy to a vast network of specialized algorithms, each optimized for specific tasks and all working together in perfect coordination. The human brings creativity and insight, and the ability to imagine new possibilities, but the network brings efficiency, accuracy, and the ability to process information on scales that no individual mind could handle. This raises an uncomfortable question. Are we actually at the peak of evolutionary achievement, or are we just one possible solution among many? Are consciousness and intelligence as we understand them the ultimate goals of evolution, or are they just interesting side branches that happen to emerge under very specific conditions? Our alternate timeline suggests that evolution doesn't have goals in the way we typically think about them. It doesn't prefer consciousness over unconsciousness, complexity over simplicity, or intelligence over pure efficiency. It simply finds ways for information to persist and replicate. And sometimes those ways happen to create minds that can wonder about their own existence. But here's what makes our actual timeline so precious. We're not just the products of evolution, we're evolution becoming aware of itself. For the first time in Earth's history, matter has organized itself in such a way that it can contemplate its own organization. We are quite literally the universe waking up and asking questions about its own nature, and that awakening came so close to never happening. If atmospheric oxygen levels had been just a little lower, if the ice ages had been just a little more severe, if the genetic innovations that enabled complexity had never occurred, we might be living in that alternate world of eternal bacterial sophistication. The difference between our timeline and that one might be nothing more than a few random molecular events that happen to occur at exactly the right moment in exactly the right way. This should give us a profound sense of responsibility. We're not just another species trying to survive and reproduce. We're the custodians of something infinitely precious, the ability of the universe to understand itself. When we do science, we're not just satisfying human curiosity. We're fulfilling a cosmic function that might be incredibly rare in the universe. Every time we discover a new physical law, every time we unravel the structure of a protein or map the orbit of a distant planet or decode the history written in ancient rocks, we're doing something that might be happening nowhere else in the observable universe. We're taking the random dance of atoms and molecules and chemical reactions that has been playing out for billions of years and finally giving it meaning. But our alternate timeline also reveals just how fragile this cosmic awakening really is. Consciousness didn't emerge because it was inevitable. It emerged because of an incredibly specific sequence of improbable events. And if it can emerge by accident, it can also disappear by accident. Climate change, nuclear war, artificial intelligence run amok, asteroid impacts, supervolcanic eruptions, any of these could potentially end the brief experiment in consciousness that began with the Cambrian Explosion. And if that happens, if intelligence disappears from Earth, there's no guarantee it would ever emerge again. We might revert to something very much like our alternate timeline, a world of sophisticated but unconscious information processing that never again produces minds capable of wondering about their own existence. This possibility should haunt us, not because death is inherently bad, after all individual death is a natural part of life, but because the death of consciousness would represent the end of meaning itself. Without minds to interpret and understand and appreciate it, the universe would continue to exist, but it would exist without purpose, without beauty, without the kind of significance that comes from being observed and understood. It would be like the most incredible symphony ever composed playing in a universe with no ears to hear it, the most beautiful painting ever created hanging in a gallery with no eyes to see it. All the complexity and sophistication and elegance of physical law would continue to unfold, but there would be no awareness to appreciate it. But let's not end on such a dark note, because our alternate timeline also reveals something hopeful about the nature of existence itself. Even in a world without consciousness, evolution found ways to create incredible beauty and sophistication. The bacterial megasystems, the temporal specialists, the crystalline entities, these aren't lesser forms of life. They're alternative forms of excellence that achieve things we can barely imagine. This suggests that the universe has an inherent tendency toward complexity and beauty, even in the absence of minds to appreciate it. The physical laws that govern reality seem to naturally give rise to intricate patterns, elegant structures, and sophisticated forms of organization. Consciousness might be the universe's way of appreciating itself, but even without consciousness, the universe would still be worth appreciating. And who knows? Maybe in our alternate timeline, given enough time, say another billion years, some form of awareness might eventually emerge from those bacterial networks or crystalline matrices. Maybe consciousness is such a powerful evolutionary advantage that it would eventually find a way to bootstrap itself into existence, even starting from completely different biological foundations. Or maybe our alternate Earth would develop forms of awareness that are so different from our own that we wouldn't recognize them as consciousness at all. Maybe the bacterial megasystems would eventually develop something like collective consciousness, not individual self-awareness, but a form of planetary awareness that experiences the Earth as a single, unified entity. Imagine a form of consciousness that experiences geological time directly, that feels the slow drift of continents as we feel the beating of our hearts, that experiences ice ages as we experience seasons. It would be a form of awareness so alien to our own that communication between us might be impossible, but it would still represent the universe coming to know itself in a completely different way. These possibilities remind us that consciousness and intelligence aren't fixed categories with clear boundaries. They're points on a vast spectrum of information processing possibilities, and we've only explored a tiny corner of that spectrum. Our form of awareness, individual, biological, operating on timescales of seconds and minutes and years, is just one possible solution to the problem of how matter can organize itself to understand its own organization. But it's our solution. It's the form of consciousness that happened to emerge from the particular sequence of events that led to the Cambrian Explosion and everything that followed. And even if it's not the only possible form of consciousness, even if it's not the best possible form of consciousness, it's ours. It's the lens through which we experience existence, the foundation of everything we value and cherish and find meaningful. And that brings us back to the central question raised by our alternate timeline. What do we do with this incredible gift? How do we live up to the responsibility of being the universe's way of understanding itself? How do we honor the cosmic lottery win that made our existence possible? The answer isn't simple, and it's not the same for everyone. But I think it starts with wonder, with maintaining that sense of awe and curiosity that drove us to ask this question in the first place. Every time we look up at the night sky and wonder what's out there, every time we peer into a microscope and marvel at the complexity of a single cell, every time we contemplate the vastness of deep time or the intricacy of quantum mechanics, we're fulfilling our cosmic function. We're doing what the universe created us to do. We're paying attention. We're noticing. We're caring about the incredible, improbable, beautiful reality that we're part of. And maybe that's enough. Maybe the fact that we can imagine alternate timelines where complexity never emerged, where consciousness never developed, where the universe remained forever unconscious of itself, maybe the fact that we can conceive of these possibilities and feel moved by them is proof that we're already succeeding at our cosmic mission. Because in the end, that's what separates us from our alternate timeline. It's not just that we're conscious, it's that we can imagine what it would be like not to be conscious. It's not just that we exist, it's that we can contemplate the profound improbability of our own existence. It's not just that we're alive, it's that we can appreciate how precious and fragile and unlikely life really is. We are the universe's way of appreciating itself, and every moment of wonder, every flash of understanding, every experience of beauty or love or curiosity is a victory against the cosmic silence that might otherwise reign supreme. But there's something else our alternate timeline teaches us, something that might be even more important than our role as cosmic observers. It shows us that consciousness isn't just about understanding the universe. It's about creating meaning within it. In our imaginary world of bacterial megasystems and crystalline entities, there's incredible complexity and sophisticated information processing. But there's no meaning in the way we understand it. There's no love, because there are no individuals capable of forming emotional bonds. There's no art, because there's no imagination to conceive of beauty beyond immediate function. There's no science, because there's no curiosity to ask questions about the nature of reality. All of these things, love, art, science, music, literature, philosophy, friendship, hope, these aren't just byproducts of consciousness. They're consciousness actively creating meaning in a universe that doesn't inherently possess meaning. They're ways of taking the raw material of existence and transforming it into something worthy of being experienced. And this is perhaps our most important cosmic function. We're not just the universe observing itself. We're the universe creating reasons for itself to be worth observing. Every poem ever written, every song ever composed, every act of love or kindness or creativity is a declaration that existence has value beyond mere survival and reproduction. This puts our existence in an entirely different light. We're not just incredibly lucky accidents who happen to emerge from an improbable evolutionary process. We're active participants in the universe's search for meaning, co-creators in an ongoing project to make existence itself worthwhile. And that project is far from complete. We've only scratched the surface of what consciousness might be capable of. We're still learning how to love better, how to create more beautiful art, how to ask more profound questions about the nature of reality. We're still figuring out how to use our awareness to make existence more meaningful, not just for ourselves, but for all conscious beings. This ongoing project of meaning creation might be the most important thing happening anywhere in the universe. And if our alternate timeline teaches us anything, it's that this project isn't guaranteed to succeed. Consciousness can emerge and then disappear again. The universe's brief experiment with self-awareness could end tomorrow, and there's no cosmic insurance policy that would bring it back. That's what makes every moment of consciousness so precious. Every experience of wonder, every act of creation, every moment of connection between conscious beings is a small victory against the vast unconsciousness that dominated our planet for billions of years and might dominate it again. But it's also what makes our future so full of possibility. If consciousness emerged once through an incredibly improbable sequence of events, who's to say it can't evolve into forms we can't even imagine? Who's to say that the brief flicker of awareness that began with the Cambrian Explosion can't grow into something that illuminates the entire cosmos? Maybe our descendants will find ways to preserve consciousness beyond the death of individual bodies, creating forms of awareness that persist across cosmic epochs. Maybe they'll learn to communicate with the kinds of alternative intelligence that might exist in our universe, the planetary minds, the quantum computers made of living matter, the crystalline entities that think in geological time. Maybe they'll even find ways to seed consciousness throughout the galaxy, ensuring that the universe's experiment with self-awareness doesn't end when our sun dies or when our planet becomes uninhabitable. Maybe the improbable accident that was the Cambrian Explosion will ultimately prove to be not an accident at all, but the first step in consciousness conquering the cosmos. Or maybe none of that will happen. Maybe consciousness will remain a brief local phenomenon, a tiny bubble of awareness in an otherwise unconscious universe. Maybe we'll never find other intelligent life, never transcend our biological limitations, never spread beyond our single pale blue dot. But even if that's true, even if we remain forever isolated in time and space, we'll still have achieved something miraculous. We'll have taken a universe that was unconscious of itself for over 13 billion years and given it, however briefly, the ability to wonder at its own existence. We'll have transformed random quantum fluctuations and chemical reactions and evolutionary accidents into love and art and science and philosophy. We'll have created meaning where none existed before, found beauty in mathematical equations and distant galaxies, and the intricate dance of molecules that makes life possible. And in doing so, we'll have justified the entire cosmic project. Every star that burned, every planet that formed, every random mutation that contributed to our existence. All of it will have been worth it for the simple fact that consciousness emerged and looked back at the process that created it and said, "This is beautiful, this is meaningful, this is worth preserving and celebrating and trying to understand." That's the ultimate lesson of our alternate timeline. It shows us a universe that could have been incredible in its own way, but would have lacked the one thing that makes any of it matter: awareness itself. It reminds us that consciousness isn't just another biological function like digestion or reproduction. It's the universe's way of experiencing itself, of creating meaning within itself, of transforming mere existence into something worthy of celebration. And we are the temporary custodians of that cosmic awakening. Every choice we make, every relationship we build, every moment of wonder we experience is part of consciousness's ongoing project to justify its own existence. So the next time you look up at the night sky, remember that you're not just seeing distant points of light. You're seeing the raw material from which consciousness emerged, the cosmic furnaces that forged the elements that make up your body, the vast spaces across which meaning had to travel to reach your mind. And remember that in all those billions of stars and trillions of planets, there might be nothing else quite like what's happening in your head right now. The miracle of matter organized in such a way that it can contemplate its own organization, the impossible made manifest in the simple fact that you exist and are aware that you exist. That's worth celebrating, that's worth protecting, and that's worth sharing with anyone else who's willing to look up at the sky and wonder what it all means. Because in the end, we're all in this together, temporary participants in the universe's brief experiment with consciousness, co-creators in an ongoing project to make existence itself meaningful, inheritors of the most improbable gift in cosmic history. The Cambrian Explosion gave us life. What we do with that life is up to us. But here's where this story takes a turn that'll make you question everything you think you know about evolution and consciousness. Because our alternate timeline isn't just a thought experiment about what didn't happen, it's a mirror reflecting back at us, showing us truths about our own existence that are so profound they'll change how you see yourself and your place in the cosmos. Right now, as you're listening to this, you're carrying the legacy of the Cambrian Explosion in every cell of your body. Your eyes, those incredible biological cameras that can detect a single photon of light, are direct descendants of the first primitive eye spots that appeared during that explosive burst of innovation. Your nervous system, capable of processing millions of bits of information every second, evolved from the simple neural networks that first allowed Cambrian creatures to coordinate movement and respond to their environment. Even your emotions, your capacity for love and fear and wonder, trace their roots back to that ancient arms race between predators and prey. The fight-or-flight response that makes your heart race when you're scared. That's a gift from creatures who lived over 500 million years ago, organisms that had to develop split-second decision-making abilities to survive in the world's first complex ecosystems. But what's truly mind-blowing is that you're not just carrying the biological legacy of the Cambrian Explosion, you're carrying its philosophical legacy as well. Every question you've ever asked, every moment of curiosity you've experienced, every time you've looked at something beautiful and felt that inexplicable sense of awe, all of that traces back to the moment when evolution first created nervous systems complex enough to process abstract information. Think about that for a second. The very fact that you can contemplate this alternate timeline, that you can imagine a world where complexity never emerged, is itself proof of just how extraordinary the Cambrian Explosion really was. You're not just thinking about evolution, you're evolution thinking about itself. But here's where things get really unsettling. Because if the Cambrian Explosion was such an improbable event, if it required such a precise alignment of factors that it might never have happened at all, then we have to confront a terrifying possibility. We might be alone. Not just on Earth, not just in our solar system, but in the entire observable universe. For decades, we've assumed that if life can emerge once, it can emerge anywhere. We've built our search for extraterrestrial intelligence on the assumption that evolution naturally tends toward complexity and consciousness. But our alternate timeline suggests that this assumption might be catastrophically wrong. What if most planets that develop life never make it past the bacterial stage? What if the universe is filled with worlds just like our imaginary Earth, teeming with microbial sophistication, but forever locked out of the kind of complexity that leads to consciousness? What if when we point our radio telescopes at the stars and listen for signals from alien civilizations, we're hearing nothing because there's nothing to hear? This is the great filter hypothesis in its most chilling form. The idea that somewhere between the emergence of life and the development of spacefaring civilizations, there's a barrier so difficult to cross that almost no species ever makes it through. And the Cambrian Explosion might be that barrier. Picture this. Across the galaxy, there might be millions of planets covered in bacterial mats just like the ones in our alternate timeline. Worlds where evolution has been running for billions of years but never quite managed to create the complex multicellular life that leads to intelligence. Planets where the closest thing to consciousness is the distributed decision-making of vast microbial networks. From space, these worlds might look vibrant and alive. Their atmospheres might be rich with the chemical signatures of biological activity. But if you could somehow visit them, you'd find something eerily similar to our alternate Earth. Sophisticated but alien forms of life that process information on scales we can barely comprehend, but that never developed the integrated awareness necessary for consciousness. And here's the part that should keep you awake at night. If this is true, if consciousness is really that rare in the universe, then when we destroy habitats, drive species extinct, or put our own civilization at risk through war or environmental destruction, we're not just endangering life on Earth. We might be endangering the only consciousness in the observable universe. Every time a species goes extinct, we're potentially losing millions of years of evolutionary information that contributed to the incredible chain of events that led to consciousness. Every time we damage an ecosystem, we're potentially weakening the biological foundation that supports the universe's only known experiment in self-awareness. But let's dig even deeper into what this means for how we understand ourselves and our place in reality. Because our alternate timeline doesn't just tell us that consciousness is rare, it tells us that consciousness is weird. Really, really weird. In our imaginary world of bacterial sophistication, information processing happens, but it's distributed, non-integrated, unconscious. The bacterial megasystems can solve problems that would challenge our best supercomputers, but they never experience the solution. They can coordinate responses across planetary scales, but there's no central awareness that experiences the coordination. It's like having the most powerful computer network ever built, capable of running incredibly sophisticated programs, but with no operating system that could ever display the results on a screen. All that processing power, all that information manipulation, but no window into the process, no experience of what it's like to be that system. This reveals something profound about consciousness that we often take for granted. It's not enough to process information. It's not enough to respond to environmental stimuli. It's not even enough to solve complex problems or coordinate sophisticated behaviors. Consciousness requires something else entirely. The integration of all that processing into a unified subjective experience. And that integration is so strange, so different from anything else we know about in physics or chemistry or biology, that some philosophers and scientists have argued it might be fundamentally inexplicable. It's what's called the hard problem of consciousness. Not just explaining how the brain processes information, but explaining why there's something it feels like to be a conscious being at all. Our alternate timeline makes this mystery even more mysterious, because it shows us that you can have incredible sophistication, vast information processing capabilities, even forms of planetary intelligence, without ever developing the subjective experience that makes consciousness so special. It's as if consciousness is not just rare in the universe, but weird in the universe. It doesn't fit neatly into our understanding of how physical systems work. It seems to require not just complexity, but a very specific type of complexity that might be incredibly difficult to achieve. And this brings us to perhaps the most profound question of all. If consciousness is so rare and so weird, what does that tell us about the nature of reality itself? Are we living in a universe where consciousness is an accidental byproduct of physical processes, a happy accident that happened to emerge under very specific conditions? Or are we living in a universe where consciousness is somehow fundamental, where the physical laws themselves are designed to eventually give rise to awareness? Our alternate timeline can't answer that question definitively, but it does suggest that consciousness isn't inevitable. It's not the natural endpoint of evolution, or the obvious result of increasing complexity. It's something much stranger and more precious. A rare form of organisation that allows matter to experience its own existence. But here's what makes this both terrifying and inspiring. If consciousness really is that rare, that precious, that improbable, then every moment of awareness becomes infinitely valuable. Every experience of beauty, every flash of understanding, every moment of love or wonder or curiosity becomes a victory against the cosmic odds that try to prevent it from ever existing. You're not just a person living your life. You're a temporary arrangement of matter that has somehow achieved the impossible, the ability to know that it exists, to experience beauty and meaning, to contemplate the vastness of space and time and find it worthy of wonder. And that's not just rare. It might be unique. In all the observable universe, with its hundreds of billions of galaxies and trillions of stars and countless planets, the particular pattern of neural activity happening in your brain right now might be the only thing of its kind. The thoughts you're thinking, the emotions you're feeling, the sense of being yourself, it might be the rarest phenomenon in existence. This should change everything about how we think about our lives and our responsibilities. We're not just individuals trying to survive and find happiness. We're custodians of something infinitely precious. The universe's only known experiment in self-awareness. Every choice we make, every relationship we build, every moment of consciousness we experience is part of the cosmos coming to know itself. And that means we have a responsibility not just to ourselves or our families or our species, but to existence itself. Because if consciousness can emerge from the random dance of atoms and molecules, if awareness can bootstrap itself into existence through the improbable sequence of events we call evolution, then it can also disappear just as randomly. Climate change, nuclear war, asteroid impacts, the gradual cooling of the sun, any of these could potentially end the brief experiment in consciousness that began with the Cambrian Explosion. And if that happens, if intelligence vanishes from Earth, our alternate timeline suggests there's no guarantee it would ever emerge again anywhere else. So here we are, standing on that same beach where we began, but now with eyes wide open to the cosmic lottery we've won. The Cambrian Explosion wasn't just a chapter in Earth's history. It was the chapter that made every other story possible. Without it, there would be no stories at all, just silence stretching across eons, brilliant in its own alien way, but forever unable to appreciate its own brilliance. We are not just alive. We are the universe finally awake enough to marvel at itself, and that's worth everything.